Hi everyone. So for this lecture video, we will be discussing logarithmic equations and inequalities. So for our objectives, at the end of the video, the learners are expected to first distinguish between logarithmic functions, logarithmic equations, and logarithmic inequalities. 2. Illustrate laws of logarithm. And lastly, you are to solve logarithmic equations and inequalities. Okay, so we are going to distinguish these three. So we have functions, equations, and inequalities. So let's start with logarithmic equation. So for the definition, we define the logarithmic equation as an equation containing a variable in logarithmic equation. So take note that the logarithmic form is simply a rearrangement of an equation written in exponential form. So the same numbers are used, but they are written in a different order. So later on, we will be discussing the form or the transformation of exponential equation to logarithmic equation. So here are some examples of logarithmic equation. So we have the logarithm of 27 with base x is equal to 3. The logarithm of 2x plus 5 with base 3 is equal to 2. The logarithm of x with base 9 plus logarithm of x minus 6 with base 9 is equal to 3 over 2. And then the logarithm of x plus 3 with base 0.5 is equal to negative 5. The logarithm of 256 with base 1/4 is equal to 3x over 7. And then lastly, the logarithm of 2x plus 1 with base 2 is equal to the logarithm of x plus 2 with base 2 minus the logarithm of x minus 1 with base 2 plus 1. So here are the structure of logarithmic equation. So this is how it looks like. Okay, so let's proceed to logarithmic inequality. So the logarithmic inequality is an inequality that involves logarithm. So here, take note that in logarithmic inequalities, we use the symbols greater than or equal to, or less than or equal to. So here are some examples. The logarithm of 5x is greater than or equal to 2. The logarithm of 5 plus logarithm of x less than 2, the logarithm of x less than negative 2, the logarithm of 3x plus 5 greater than 2, the logarithm of x with base 2 is less than the logarithm of x plus 4 with base 2. And lastly, the logarithm of 3x minus 1 greater than the logarithm of 4 minus x. So take note that some of the examples has no base. Okay, so that means that the base there is 10. So later on, we will be discussing the common and natural logarithm. Next, so the logarithmic function, it is defined as for all positive real numbers x and b, x greater than 0, b is greater than 0, and b should not be equal to 1. So the inverse of the exponential function y is equal to b raised to x is the logarithmic function y is equal to the logarithm of x with base b, or it can be f of x is equal to the logarithm of x with base b. We have a note here that y is equal to the logarithm of x with base b is read as y equals the logarithm of x base 2, or y equals the logarithm base 2 of x. So we have one example here. So we have y is equal to the logarithm of 2x with base 3. Now to summarize, so here are the differences of these three. So for logarithmic equations, so we have an equality here. So an equation involving logarithms. So we have the logarithm of 9 with base x is equal to 2. So we have the equal sign here. For logarithmic inequality, we use the inequality, okay? The inequality symbol, so it can be greater than, less than, greater than or equal to, less than or equal to. So the example here, the logarithm of 10 with base x greater than 2. And then for logarithmic function, we have a function of the form f of x is equal to the logarithm of x with base b, wherein b should be greater than 0 and b should not be equal to 1. So the example here, f of x is equal to the logarithm of 9 with base b. Now, in this lecture video, we will be focusing on the logarithmic equation and logarithmic inequality. So there will be a separate lecture video for logarithmic function. Now, let us recall that we can also rewrite the exponential equation to logarithmic equation. We must first recall how we solve the exponential equation. So let's try to answer these three. So the instruction here, we are going to solve for x. Okay, so let's try number one. So number one says 3 raised to 5 is equal to x. Now, when we say 3 raised to 5, so recall that we can rewrite it as 3 times 3 times 3 times 3 times 3. So it means that we multiply 3 by itself 5 times. Okay? So using our calculator, 3 raised to 5 is equivalent to 243. Therefore, the x here is equal to 243. Okay, so we're done with number 1. Number 2, 36 raised to 1 half is equal to x. Now, we know that any number raised to 1 half can be written as the square root of the number, okay, of the base. Now, since our base is 36, we can rewrite it as the square root of 36. Okay, so the square root of 36 is equal to x. Now, let us take into consideration, since we know that the square root of 36 is 6. But if we're going to multiply 6 by itself, okay, we get 36. But if we are also going to multiply negative 6 by itself, we also get 36. Therefore, it means that if we get the square root of a number, we have two possible values for x. So therefore, our x here should be um, plus minus 6. Okay, so here's the answer for number 1 and number. Next, for number 3, okay, 27 raised to 2/3 is equal to x. Now, from the example number 2, we can already get an idea as to how we are going to write this one. So, since the denominator of the exponent here is 3, so therefore we are going to get the cube root of the base. Okay, the cube root of 27, and then since the numerator is 2, so we square the base by 2. Okay, so we rewrite this exponential equation as the cube root of 27 squared. Now, using your calculator, 27 squared is equal to 729, cube root of 729. Okay, and then getting the cube root of 729, we get an x is equal to 9. Okay, now as compared to example number 2, we have two possible values for x. Now here, we only have one, because if we are going to multiply negative 9 by itself, Okay, negative times negative is positive, but if we are going to multiply another negative number, so this will become negative. Now, it will not anymore be equivalent to the other side of the equation since it is positive. Okay, so therefore the answer for number 3 is x is equal to positive 9. Now let's try another examples. Okay, so let's try this one. So we have 5 raised to x is equal to 625. Now recall that for us to be able to solve this one, there should be the same base. Okay, so there should be the same base for us to get the value of x. Now let us try to rewrite 625 with base 5. So how many times are we going to multiply 5 by itself to get 625? Now you can use your calculator or you can use trial and error in getting the answer. Now here, we know that 625 can be written as 5 raised to 4. Now since both of these numbers has the same base, now we can now solve for the exponent. So since the exponent here is x, we can equate x equal to 4. Since both of their bases are equal, so that means their exponents are also equal. So therefore, the x here in number 1 is equivalent to 4. So we're done with number 1. Next, for number 2, we have 1/3 raised to x. Okay, 1/3 raised to x is equal to 81. Now here, we must rewrite 1/3 or 81, okay, with the same base. Okay, so we know that you can also try trial and error or you can use your calculator in getting the base of 81 that it should be the same with 3. Okay, so we can try 3 times 3 is 9 times 3 27. So times 3 is 81. So that means that we can rewrite 81 as 8, uh, no, 3 raised to 4, 3 raised to 4. Okay, so let us write it down. So we can rewrite this as 1/3 x is equal to 3 raised to 4. So take note that they do not have the same base. Now, by loss of exponent, we can rewrite this one, this portion, the values on the left side of this equation as 3 raised to negative x. Okay, so 3 raised to 4. So therefore, we can now solve for x, which is x is equal to negative x is equal to 4. Now multiply both sides by negative 1 to remove the negative sign here. So multiply both sides by negative 1. So we get an x that is equal to negative 4. Okay, so for number 2, the x value here is negative 4. Okay, next. Number number 3. For number 3, we have here 9 raised to 2x minus 1 is equal to 3 raised to 8x. Now, let us try to take a look at the bases. Okay. So both of these are multiple of each other. So we can rewrite 9 with the base 3. Okay, so we know that 3 times 3 is 9. Okay, so we can rewrite it as 3 squared and then copy the exponent. 2x minus 1 is equal to 3 raised to 8x. So as you can see, they already have the same base. So we can now evaluate the exponents. So if they are equal, so that means that the exponents are also equal. So using distributive property, distribute natin to. So magiging siyang 3 raised to 4x minus 2 is equal to 3 raised to 8x. Now, let us now equate both of the exponents for us to get the value of x. Okay? So the exponent 4x minus 2 is equal to 8x. So transpose natin ito. So combine all like terms. 4x minus x is equal to 2. 4 minus x is 4x. Yeah, negative is equal to 2. So divide both sides by negative 4. So we got an x of x is equal to negative 2 over 4 or 1 half. Okay, so therefore, the answer in number 3 is x is equal to negative 1 half. Now, this exponential equations can also be solved. They can also be solved using logarithmic equation. So we have two special classifications of logarithm. We have the common logarithm and natural logarithm. So when we say common logarithm, these are logarithms with base b is equal to 10 and are written as the logarithm of x, which is equivalent to the logarithm of x with base 10. And then when we talk about natural logarithm, these are logarithms to the base e, which is e here is not a variable. Okay, so this is not a variable. It has a value which is approximately equivalent to 2.7128. Okay, and are written as the ln x, which is equivalent to the logarithm of x with base e. Now, as you can see, we can also rewrite the natural logarithm as common logarithm, wherein since we know, or by definition, that the base here is e, so here we have the logarithm of x with base e, okay, or equivalent to ln x. Okay, so in this table, okay, we are showing to you the exponential form and the logarithmic form. So as you can see, these are just the rearrangement of the exponential form or the exponential equation. So we have 2 raised to 10 is equal to 1024. And then converting it to logarithmic form, take note they are just inverses of each other. Okay, so we have the logarithm of 1024 with base 2, ito po yung base, and then the logarithm of 1024 with base 2 is equal to 10. So basically, yung nandito sa right portion natin are just the exponent of the equation. So let's try another example. We have 3 raised to negative 5 is equal to 1 over 243. Now, using logarithm, we can rewrite it as the logarithm of 1 over 243 with base 3 is equal to negative 5. Next example, we have 2/3 squared is equal to 4 over 9. So we can rewrite it as the logarithm of 2/3, the logarithm of 4 over 9 with base 2/3 is equal to 2. Then, next example, 3 squared is equal to 9. Okay, so we have the logarithm of 9 with base 3 is 2. So here we have a variable, so we can assign any number to this one, to this model. So b raised to c is equal to a. So we can rewrite it as the logarithm of a with base b is equal to c. Next, so we will be discussing the properties and laws of logarithm. So this will help you solve for the logarithmic equation since we will be dealing with variables. So here, let b and x be real numbers such that b greater than 0 and b should not be equal to 1. So the b here is the base. So if we are going to recall the form of exponential equation, the base should not be equal to 1 and it should be greater than 0. Okay, so the first property, if we have the logarithm of 1 with base b is equal to 0, so this means that um, if we have b raised to 0, so this is equivalent to 1 because any number raised to 0 is equivalent to 1. For property number 2, the logarithm of 1 with base b is just equal to 1. So we can rewrite this one as b raised to 1 is equal to b. Any number raised to 1 is just itself. And number 3, the logarithm of b raised to x with base b is just x because basically b raised to x is equal to itself, b raised to x. And then lastly, if x is greater than 0, then the logarithm, uh, b raised to the logarithm of x with base b is just equivalent to x since we can cancel this 2. Next, for the properties of logarithm, so this is for natural logarithm. So we are using ln. So the base here is e. So let b and x be real numbers such that b is greater than 0 and b is not equal to 1. So 1, first, ln 1 is equal to 0. Number 2, ln e is equal to 1. 3, ln of e raised to x is just x. And then number 4, if x is greater than 0, then e raised to ln x is just equal to x. Okay, for the laws of logarithm, let b be a positive number with b not equal to 1. We let x, y, and z be any real numbers with x greater than 0 and y is greater than 0. So for number 1, um, we have logarithm of the product of x and y with base b is equivalent to the logarithm of x with base b plus the logarithm of y with base b. So very this is very similar to the laws of exponent. Okay, so if we are going to multiply, we add the exponents. Okay, so that's why we add the logarithm of x and y here, given that they have the same base. Number 2, the logarithm of the quotient of x and y with base b is just equal to the logarithm of x with base b minus the logarithm of y with base b. So the same concept. So if we are going to divide, given that they have the same base, we divide. We subtract the exponents. And lastly, the logarithm. of x raised to z with base b is just equal to the z times the logarithm of x with base b. Now, please be familiarized with the laws and the properties of logarithm, since this will help you to solve our logarithmic equations. So to add, we also have the change of base formula. So it is defined as let A, B, and X be positive real numbers with A not equal to 1 and B not equal to 1. So we write it as the logarithm of X with base B is equal to the logarithm of X with base A over the logarithm of B with base A. Now, this is equivalent to the logarithm of X over the logarithm of B. Now, for one-to-one property of logarithmic functions, for any logarithmic functions, f of x is equal to the logarithm of x with base b if the logarithm of u with base b is equal to the logarithm of v with base b, then that means that the u and v here is equivalent since they have the same base and u and v is the same. Okay, so to apply the laws and the concepts that we had earlier, let's try to solve the following logarithmic equations. Okay, so the first one we have the logarithm of x plus 1 with base 4 is equal to 2. Now, in this case, okay, we will be transforming this logarithmic equation to exponential equation. So we know that the 4 here is the base. So we can rewrite here, this is the base, this is the exponent. So we can rewrite this one as 4 raised to 2 is equal to x plus 1. Now we know that 4 raised to 2 is 16. So 16 is equal to x plus 1. We can now combine similar terms. So the constant here is 1. So transpose 1. 16 minus 1 is equal to x. So therefore, our x here is just 15. Now, by commutative property, this is just the same. So x is equal to 15 or 15 is equal to x is just the same. Now to verify, okay, we can verify our answers if it is correct. So we can substitute the value of x to the logarithmic equation. So to check, you can use your calculator. So we have the logarithm of x plus 1 with base 4 is equal to 2. So since we already got the answer for x, so the logarithm of 15 plus 1, 15 plus 1 with base 4 is 2. Okay, so since we are just checking, so let us put the question mark there. So using the calculator, let's check. So the logarithm of 4, 16 rather, with base 4 is equal to 2. Okay, so using the calculator, we check that uh, it is equivalent to 2. Okay, so therefore, our answer here is x is equal to 50. Next, the logarithm of 20x is equal to 2. Now, in this case, we do not have the base here. Okay, so by definition, if there is no base here, it means that the base there is 10. So, applying again the concepts and definitions that we had, We rewrite this as an exponential equation. So we can write this as 10 raised to 2 is equal to 20 20x. Now, simplifying, 10 squared is 100, okay, 20x. Dividing both sides by 20 to remove the coefficient of x. So therefore, x here is equivalent to 100 divided by 20 is 5. Now to verify, we will again substitute the value of x to the logarithmic equation. So the logarithm of 20 times 5 is equal to 2. Okay, so using your calculator, the logarithm of 100 is equal to 2. Therefore, the answer here is correct. Next example. Now, in this case, both left and right side of the equation has a logarithm. Okay. So in this case, we will be applying the laws of logarithm. So for the first one, we have the logarithm of 18 with base 3 is equal to, since this is addition, it means that the exponents here are multiplication. So since they have the same base of 3, we can rewrite this as the logarithm of 2x is equal, the logarithm of 2x with base 3. Now, since they already have the same base, we can now solve for the exponent. So we can now equate 18 is equal to 2x and then divide both sides by 2. We can now get the value of x, which is 18 divided by 2 is 9. Okay, so to verify, substitute the value of x, which is 9, to the logarithmic equation. So the logarithm of 18 with base 3 is equal to the logarithm of 9 with base 3 plus the logarithm of 2 with base 3. Now, looking at it, okay, since we applied the first property on the first part, so we can multiply also 9 and 2. So the logarithm of 9 times 2 is 18. So therefore, we can say that both of this logarithm are equivalent. The logarithm of 18 is equal to the logarithm of 18 with base 3. So obviously, both of these are equivalent. Okay, so this is approximately using the calculator. So we have 2.6309. So the same din siya, 2.6309. So let's proceed to the next example. We have the logarithm of x plus 2 with base 2 plus the logarithm of 3 with base 2 is equal to the logarithm of 27 with base 2. Now, in this case, since we are using addition here, now we know that we are going to divide this one. Okay, since um, they have the same base. Okay, so we can rewrite this one as the logarithm of 2, and then multiply x plus 2, and then 3, okay, is equal to the logarithm of 2, the logarithm of 27 with base 2. Okay, so let me repeat again. So in this case, since this is addition, okay, using the laws and properties of logarithm, we are going to apply multiplication. Okay, so since they have the same base, we can rewrite this one as the logarithm of x plus 2 times 3 with base 2 equals the logarithm of 27 with base 2. Okay, so simplifying the logarithm of 2, simplifying, so this will become 3x plus 6, the logarithm of 3x plus 6 with base 2. Yeah, sorry for that. So that is base 2. Okay, so this is equivalent to the logarithm of 27 with base 2. Now, since they already have the same base, so we can now equate 3x plus 6 is equal to 27. 3x, combine similar terms, so 27 minus 6. So 3x is equal to 21. Divide both sides by 3. So we have x is equal to 7. Now to verify, we can also we can substitute the value of x to the logarithmic equation. So the logarithm of 7 plus 2 is 9. So the logarithm of 9 with base 2 plus the logarithm of 3 is equal to the logarithm of 27 with base 2. Now, applying the concepts that we had, so we know that 9 times 3 is 27. So, obviously, they are equal. So, the logarithm of 27 with base 2 is equal to the logarithm of 27 with base 2. Okay, so you can just check using your calculator what is the value of the logarithm of 27 with base. Okay, so for the next lecture video, we will be discussing the logarithmic inequality. Thank you so much.